Okay, on to our third and final installment of Polymer Matrix Composites. We left off with just the types of reinforcing fibers, and so I've listed them here and give some details. We'll go over that. Also, just understand that all of these reinforcing fibers are capable of putting in all these different types of forms. And I showed you earlier what some of those fabrics look like, some of those weaves. But you can get individual yarns and strands. You can do rovings, which are those kind of combined together in one long axis. Then there's those woven fabrics and weaves that I showed you earlier. There are mats that are just kind of pressed together. And then, of course, you can also get chopped strands. Now, typically in a PMC composite structure, the actual reinforcing fibers usually comprise or make up about 20 to 50% by weight of that PMC. Sometimes a little bit higher, but traditionally approximately somewhere in this range between 20 and 50% by weight, the fibers inside of a PMC product. Okay, so let's talk now just briefly about some of these three basic types of fibers. And the first one, of course, is just glass. It is the most widely used, the least expensive, the most available. It has fairly good, adequate mechanical properties for the most part. There are a lot of variety of different types of these fibers. Glass fibers, there's what they call E-glass, which is electrical. They call it S is structural glass, and there's all different classifications or types of glass fibers. Again, it's least expensive, most widely available, but its downfall here relatively is the relatively heaviness of it. It's a fairly heavy fiber compared to these other basic two here, so it's relatively heavy in its usage. Now, the second type is an aramid fiber. You've heard it called its trade name of Kevlar by DuPont. In fact, they're the only folks that make it. And it has significant increase in greater toughness and is much lighter weight than glass fibers in general. And it's known, of course, for its very high impact resistance. It is sort of its anti-ballistic properties. Is used, and of course, in the vest, the bulletproof vest that you see people wearing, both from some of our first responders and military folks, along with the actual military vehicles, aircraft, etc., use these Kevlar panels for its anti-ballistic properties. Now, one thing is very distinctive about it, just physical appearance, is a very, very beautiful golden color to it. This aramid or Kevlar fiber does, and I used to have some samples of it, but since gone away. But I was one of the things I showed when I had this stuff. It is almost just to get a very thin weave of this, a very thin fabric of it. It's almost impossible to cut it with just a plain pair of scissors. It is that resistance to shear and or impact. So very, very excellent material. Now, it's used for both military and also in recreational applications. There are a lot of applications that involve high impact, and I can just think of one for sure, and that is canoe rentals. How many times especially canoe rentals around any kind of whitewater, which is kind of tricky. But be that as it may, there are definite recreational applications for this Kevlar as well. Okay, finally, let's talk carbon fibers. Now, these are the higher performance of all the fibers. They have very high strength and stiffness. And in fact, I touched upon that in the first slide on composites, PMCs, and talking about a specific strength, specific stiffness of ratios, and how high they were specifically for carbon. So at any rate, now this material consists mostly of carbon, of course, and it's made from this material called polyacrylonitrile, which is PAN for short, which is obtained by heating an organic fibers, basically materials, to very, very high temperatures in absence of any air, and while they're doing this, they're pulling it in tension, and that creates these carbon fibers. All right. Now, these tensile modulus, or the modular elasticities, can range, as I told you, all the way up to 100 million psi, which is incredible. All right. 100 million psi is unbelievable, and because the steels are right around 29 million psi, so 29 million psi. So at any rate, this is significantly higher, and of course, as we said, it weighs hardly anything. It's extremely weight. Strength to weight ratios are very, very excellent, very good. It is not affected by any kind of moisture or other liquids. It does have the highest, as I told you earlier, has the highest specific strength of any of the fibers, especially at elevated temperatures. And it's, of course, widely used in a variety of advanced performance applications, ranging from industrial, aerospace, military, that kind of stuff, but also, as you very well know, within the recreational areas in industries, they have widely adapted this material in their applications of their various hardware within their own recreational sports. So this kind of wraps up the last installment here, as I said, of Polymer Matrix Composites. I did want to show you a couple of things before I turn this off. This is an excellent journal. Those of you who eventually, hopefully, may get into this field, you will be getting this, I would think. This is High Performance Composites magazine. Let me erase this, and I'll just set this on the board. Okay. All right, so this is what you typically might think of a high performance composite, something like this, or some sort of aerospace, airplane, rocket, something like that, where they'd utilize this. And as I told you about the Porsche, and anyway, this is an excellent magazine for people involved in this material field. But this is, again, sort of the norm of what you would think composites, high performance composites, would be utilized, and this is a Formula One, Lotus. But look at how it's taken over in other industries. Check this. Here we are in the world of music, classical music, and making violins, you see. So, I mean, the sky's the limit as far as the applications and using this type of material system. Truly it is, and you can see that the carbon fiber uses that, and this is obviously some sort of prepreg, actually. And so again, it's something that all mechanical engineering students coming out should be aware of, this material and where it's being used, why, and how. And I would suggest taking 4376, because that way you get an idea of how this stuff, the different manufacturing processes involved in making these type of PMC components. Okay, now one other thing. Let's go back quickly to just plastics in general. One of the things I wanted to show you, I may have mentioned it, but I didn't show it to you. But there is a recycling code for plastics, and let me see how much you can see of this. See just about all of it. Okay, so this is the recycling code for plastics, and I'll point these out to you. Number one, this little triangle, these arrows chasing themselves, is the traditional format for this recycling codes. There's 1 through 7. First one, number 1, is a PET. We didn't talk a lot about that, but every one of these little water bottles you have are all going to be made out of this PET. Very, very consumer type polymer or plastic. Number 2 is the HDP. We did talk about this in detail. This is one of the polyethylenes, high density. Number 2, you'll see that in a lot of different applications. Number 3 is a PVC. You'll see that, of course, in different applications, and in some places you might not see them. It's kind of interesting when you're shopping and stuff to look at all these different plastic containers and look up which one of these types of plastics they're made out of. Number 4 is another in the family of polyethylene. It's a low-density PE. It's low-density polyethylene, and you'll see where some of the properties engaged in these different plastics are actually used in the actual application themselves. You see why they might use HDPE over LDPE or vice versa. Number 5 is polypropylene, used in lots and lots of applications. Again, we talked about the live hinge applications. Also, a lot of bottles, juice bottles, Gatorade bottles, things like that, because again, it's so highly impact resistant, or not. I mean, as far as it's moving around, being thrown around, kind of a thing, and its lightweightness. So polypropylene is a good example of that. Of course, it's not the most impact resistant. We talked about what that was. That was the UHMWPE. But at any rate, and then number 6 is polystyrene. We didn't mention anything about polystyrenes. This is basically used and seen mostly in their foamed state. What we call expanded polystyrene, which is basically, the styrofoam trade name for Dow. And then finally, number 7 is just other. Some other type of plastic, so they just can't go on and on, or too many of them. So sometimes they just put number 7 as other. So those are the basic recycling codes 1 through 6. Now, last but not least, just a brief mention as to where plastics are, and you might think I'm kind of shooting myself in the foot here, but this is machine design. This is a magazine that I've gotten almost all my life, it seems like, and this is by engineers for engineers. I recommend all my Design 1 students to look this up and try to get it. But be that as it may, this is a really, really good magazine, and a lot of different upcoming new ideas, new mechanical elements, etc., and materials too. So, and then here's a whole issue just about plastics, making plastics parts lighter and stronger. And here's another article in that magazine, replacing metal with plastics. So I mean, it's strong, it's moving as far as the material itself. So do not discount the world of plastics in your overall engineering design material repertoire. So you must include some of these polymers and plastics, these thermoplastics, within your design material repertoire when you go out and start thinking about selecting the right material for the right application. Okay? Now, we have one last celebration of learning. Again, this last exam will be this Friday, May 8th, 7:30 a.m., and the exam ends at 10 a.m., so, that's it. When 10 a.m. hits, the exam shuts down. You don't have any extra time. So you need to start it at 7:30. There's no starting late and then thinking you're going to get the 2.5 hours. It doesn't work that way. Okay. And it's going to be the same kind of a format that the other exam we had online in Blackboard was. Multiple choice questions. I think we had 20, 25 questions, something like that. It'll be in that range. Okay, maybe a little bit more since we have a little bit more time, but it'll basic format, same format, and just again covering the material that I covered on these whiteboard lectures. Okay, That's it for now. I may have a wrap up of the whole semester kind of a thing. Maybe not. It's not a review or anything like that. So we're not reviewing anything because we're not having a comprehensive final. But I may just have a final follow up comment or something. Who knows? But we'll see. But anyway, best of luck, and we'll talk again later.